比较大。
全是你拿的手记的。
对，都是手工制的。
深圳2017年的时候，第一个就实现了卓越公交车全部电动化，15000辆全部是电动的公交车，这是世界领先的。而且整个中国的电动公交发展也是处于世界前列的，以后还是个趋势。因为电动公交的节能环保，我们的工业用电分为高峰期和低谷期，白天是1.08块，然后晚上是2毛4，也就是最高差价是8毛4，差距是很大的。如果高峰期用电太多，对整个社会的用电会造成很大的冲击，所以我们就需要做一个优化，就是说把白天高峰跟平峰的用电给减少下来，让尽量利用夜间的谷期充电。但是他们人工很难做得太好，就通过算法来引进，可以让它就是算得刚好很准确。我们刚开始想借鉴一些国外的经验，但是后来发现国外的公交发展根本还比不上深圳的发展速度，所以我们只能不停地自主的调研、自主的创新，最后才生成了这样一套算法。还剩多少个电了？咱们这个车有蓄电吗？今天天气有点热，可能耗电会比较多一点。这个项目确实是有很多创新的地方，因为以前的燃油公交车，它的调度其实很简单，你只需要满足乘客的需求就好了。但是这个充电的话，你既要考虑乘客的他上车时间段，又要考虑我什么时间适合充电，这就会发生冲突。你必须要把两者协调好。我们现在做出来的成绩，对于比如说我们试点的大梅沙线路，它大概每天能够节约600块钱。另外，我们还做了很多革新，就是说减少电池的成本。能源行业带来一些变革。减少电池的无效的那种浪费啊，这华为就尝试在做各方面的这种事情，我只是做其中一块。去过一线的做出来的东西，会考虑用户的感受，我会考虑数据的真实性，你知道怎么剔除异常的数据，知道每一行代码它会给用户实际带来什么样的体验，这样你写代码的时候，你会心里就会很有感觉。深圳夏天最热的时候35、6度吧，然后有时候会下雨，所以我们去场站的时候，一般就穿短裤拖鞋，这是最好的打扮。我们白天是跟他们充电员一起工作，看他们擦枪拔枪，到晚上的时候可能就更加辛苦了，把充好电的车挪走，再换一台车。他一般是晚上要3轮或者4轮这样的挪车。真正到了一线之后，才会了解一些细节，才能把算法设计得更细致，才能了解、体会到他们一线工人他们工作时候的细节，这样才能够照顾他们，才能考虑到他们工作时候的状态。这边堵车哪个地方堵车比较厉害啊？
哎呀，就这个科技园那里。
科技园那边啊？
最堵车了，你就在那里。
哦。就是我们了解了他们的辛苦之后，我们的每一个代码其实都会影响到他们一线的工作状况。这就需要我们的算法做得非常的灵活，非常的精致。就是我不能只以成本为目标，我要考虑多种因素，除了是经济的成本，还有管理成本，还有人的幸福感。你如果节约成本，但是降低了很多的幸福感，这个算法其实是很难普及，很难做到从1到 N 的。只有从1到N 才能真正的体现算法的价值。
We love to move and enjoy the journey. When digital and AI meet transportation, every road and every stop becomes that much easier, that much more comfortable.
Hi, are you going home? Yes. Starting navigation.
We build bridges to transport and track every every kind of cargo and freight, making its way to distant destinations. Yet we have a higher vision, still, encompassing every detail, every car, every train, every piece of cargo, every subway, and every flight, everything in its place. Sensed, connected, converged and smart, connecting routes and people alike.
我是做算法做了20多年了，大部分是交通行业的一些算法。10年前在日本读博士的时候，做过一个物流的装箱的算法，超过了世界上最好的算法，把装箱率从92%提升到97%。我的算法现在还在跑，说明这个算法还是有价值，这是我感到很欣慰的地方。我觉得算法就是要为人服务的，你如果不能给人带来幸福感，只能带来经济价值的话，我觉得这个是冰冷的算法，是没有温度的算法。
这单我们工作量也比较大。
全是你拿着手记的。
对，都是手工制的。
深圳2017年的时候，第一个就实现了卓越公交车全部电动化，15000辆全部是电动的公交车，这是世界领先的。而且整个中国的电动公交发展也是处于世界前列的，以后还是个趋势。因为电动公交节能环保，我们的工业用电分为高峰期和低谷期，白天是1.08块，然后晚上是2毛4，也就是最高差价是8毛4，差距是很大的。如果高峰期用电太多，对整个社会的用电会造成很大的冲击，所以我们就需要做一个优化，就是说把白天高峰跟平峰的用电给减少下来，让尽量利用夜间的谷期充电。但是他们人工很难做得太好，就通过算法来引进，可以让它就是算得刚好很准确。我们刚开始想借鉴一些国外的经验，但是后来发现国外的公交发展根本还比不上深圳的发展速度，所以我们只能不停地自主的调研、自主的创新，最后才生成了这样一套算法。还剩多少个电了？咱们这个车有蓄电吗？今天天气有点热，可能耗电会比较多一点。这个项目确实是有很多创新的地方，因为以前的燃油公交车，它的调度其实很简单，你只需要满足乘客的需求就好了。但是这个充电的话，你既要考虑乘客的他上车时间段，又要考虑我什么时间适合充电，这就会发生冲突。你必须要把两者协调好。我们现在做出来的成绩，对于比如说我们试点的大梅沙线路，它大概每天能够节约600块钱。另外，我们还做了很多革新，就是说减少电池的成本。整个行业带来一些变革，减少电池的无效的那种浪费啊。所以华为就尝试在做各方面的这种事情，我只是做其中一块。去过一线的做出来的东西，会考虑用户的感受，我会考虑数据的真实性。你知道怎么剔除异常的数据，知道每一行代码它会给用户实际带来什么样的体验，这样你写代码的时候，你会心里就会很有感觉。深圳夏天最热的时候35、6度吧，然后有时候会下雨，所以我们去场站的时候，一般就穿短裤拖鞋，这是最好的打扮。我们白天是跟他们充电员一起工作，看他们。
Welcome. Thanks so much for joining us at Huawei's Global Transportation Summit. In today's summit, we will share with you insights from industry leaders in the transportation sector. More specifically, we will explore how cloud-based, digital, and intelligence form the new paradigm in comprehensive transportation. To get us started, let's hand over to Mr. Wen Mengyong, the member of MPC Standing Committee and the president of China Highway and Transportation Society. Sees digital transformation and how it helps to facilitate intelligent, comprehensive transportation construction in China.
Hello everyone. I'm glad to share some ideas with you on the topic of digitalization, specifically on digital technologies enabling China's comprehensive transportation network. Transportation is a foundational, future-oriented, and strategic sector of the national economy and an important part of the service sector. The state government have always attached great importance to the transportation industry. Just in February this year, the State Council issued the guidelines on developing comprehensive national transport network, which is a very important document. This document is crucial for us to realize the new journey of the second centenary. And it also shows the transportation underpins the strategic development of our country. As you may know, China has massive transportation infrastructure. This chart reflects the scale of our transportation infrastructure. As of the end of last year, we can see from the numbers that we are in a leading position in the world in many areas. For example, by the end of last year, our high-speed railway mileage was 38,000 kilometers, and our highway mileage was 161,000 kilometers. These numbers top the world, especially our high-speed railways account for more than 50% of the world's total mileage. We have the largest ports in the world for more than 10 years. All these support the development of the national economy and society. While we acknowledge our achievements, we must also be aware of the weakness, the inadequacy and imbalance in the transportation infrastructure. In general, in my opinion, the integrated, comprehensive transportation is to some degree lagging behind. It is not well established yet. Experience of other countries shows that building an integrated and comprehensive transportation system is important for the transition from a big transportation power to a strong one. With such understanding, the guideline document sets forth that in the next 3 to 5 years, China should build a convenient, cost-effective, green, intelligent, and safe, comprehensive national transport network. We can break down this goal into two 1-2-3s. One is to construct the so-called 1-2-3 travel circles in China. That is 1 hour commuting in cities, 2-hour travel inside city clusters, and 3-hour trips between major cities. The second 1-2-3 is to build a global 1-2-3 logistics circle, which is 1 day delivery to domestic destinations, 2 days to neighboring countries, and 3 days to major global cities. In accordance with this overall goal, a transportation network of about 700,000 kilometers has been planned, including major railway lines, roads, and water transport lines, plus some important hubs of civil aviation and postal services. The main national backbone network is highlighted. and the backbone lines of a total of 290,000 kilometers is planned. The main national backbone network highlights 3 types of key coverages based on the traffic demand. The first type is the 4 poles, namely Beijing, Tianjin, Hebei, Yangtze River Delta, Guangdong, Hong Kong, Macau, and Chengdu, Chongqing metropolitan circles. The second type is the 8 city clusters in the east coast, which covers the Shandong Peninsula, the Western Taiwan Strait Economic Zone, and so on. The third type is the 9 city groups, which are mainly cities in the Midwest of China. Connecting these 3 groups, we get the 6 main axes, which is the frame of the red parallelogram. Apart from these key coverage areas, there are 7 corridors and 8 passages. Together, they constitute a 290,000 kilometers complex transportation network. When I read the guideline document, I observe 3 main features. The first one is that it optimizes the layout of our country's comprehensive transportation infrastructure. It is not about rebuilding the network from scratch, but enhancing it on the basis of the existing network. This is mainly reflected in the 5 points listed in this page: enhance interconnection, overcome weakness, focus on intermodal connections, improve network layout, and increase efficiency of the entire network. The second feature is that it promotes the integrated development of cross-modal transportation, which is mainly embodied in 3 aspects. One is the integrated transportation planning, which means we need to move from one mode transport planning to cross-modal transport planning, changing the 2D planning to 3D planning. In addition, important transport corridors and lines should be shared. For example, in a river crossing or sea crossing context, or when a transport line goes across sensitive areas. Also, communications, energy, and water infrastructure should be taken into consideration in the planning process. We also need to strengthen the construction of important transportation hubs. We know that for a comprehensive transportation system, the transportation hubs are very important. Regardless of passenger or goods transport, we rely on well-integrated transportation hubs for seamless intra- or intermodal connection. The third is to improve connection of transportation inside and outside the cities. This is because our approach to transportation development in the past was similar to the old approach to economic development. Urban planning and rural planning was separated. Now, not only do we need to connect cities with rural areas, inside the cities we also need to strengthen cross-modal connection. The third and the most important thing, I think, is to promote the quality of comprehensive transportation. In the past 30 years, we have mainly worked on expanding our infrastructure, focusing on the scale. In the next 30 years, I personally believe, and also according to the guideline, the need is to enable transportation through scientific and technological innovation. So according to the guideline, to achieve these 5 objectives, I think we need to focus on the following 6 aspects for technology enabling transportation. It is about building a brain of the transportation system, and that requires us to build 5 networks and 1 system. Specifically, we should build a brain for the comprehensive transportation system of the country and realize the connection and exchange of information for highways, railways, water, civil aviation, and postal services. It's important to have access to the information from the top and from the edge. Second, we need to build a national transportation information platform so that transportation big data of our country can be aggregated, accessible, and controllable. The second requirement is to promote the digital transformation of transportation infrastructure. And that means we need to use digital technologies to enable traditional transportation infrastructure and achieve digital in the entire life cycle of transportation infrastructure, including construction, maintenance, management, and operation. In my opinion, digitalization is the basis of intelligence. The core of intelligence is bigger computing power. And at the same time, digitalization is the prerequisite of being able to use that compute power. For example, we talked about smart railways, smart highways, smart shipping, civil aviation, and smart postal services. Digital transformation of infrastructure is the foundation, which creates conditions for the iterative evolution towards more intelligence in the future. Third, we need to build convenient and smooth integrated travel services. We need to promote the digitalization of the whole process of mobility services. One popular term is mobility as a service. In specific, it is about integrating a variety of transportation elements and modes into a unified travel service platform. Based on the concept of digital and shared services, big data technology is used to optimize resource allocation and decision making, to contribute to an efficient and traveler-centric transportation system. The fourth is to build efficient logistics and supply chain services, supporting the goal of the 1-2-3 global logistics circle. For this, we need to promote the combination of internet technologies and logistics and promote efficient and high-quality multimodal transportation, which is crucial for China's transportation system as a whole. The fifth is to build a responsive emergency assurance system. Our integrated transportation network covers 700,000 kilometers. Adding in our provincial level transportation lines, this is really a huge network. I think that to operate this network, security and reliability is essential. Therefore, it is necessary to use various technologies to dynamically monitor the structure, performance, and operational status of important transportation infrastructure. For example, we have over 1 million road bridges and hundreds of thousands of tunnels. What is the security and reliability of such major infrastructure? Pre-warning and monitoring are important to identify risks in advance. Another point is that we should monitor the entire transportation process of dangerous goods and key materials and establish an efficient emergency assurance system which covers information aggregated from air, land, and marine transport. Only in this way can our system operate safely and reliably. Finally, I think it is necessary to build an integrated transportation information service system. By fully using Beidou and other medium and low Earth orbit satellites, we can achieve global high-speed coverage without blind spots. We use 5G, big data, cloud computing, blockchain, and AI, and we can build a high-quality space, air, ground integrated transportation, communication, and information network that integrates sensing, transmission, and intelligent management and control functions. Only in this way can we effectively serve and support the operation of this comprehensive transportation network. Therefore, in my opinion, our transportation system is moving from two-dimensional to three-dimensional, from single-mode development to a comprehensive development, and from growing the scale to improving the quality. This upgrade of the transportation infrastructure will be enabled by technology and innovation. Technology enablement and innovation provide unlimited possibilities for the development of China's transportation industry. Thanks again for listening. Thank you.
Thank you, Mr. Wang Mengyong, for sharing your insights. So now, let's see how Huawei approaches the mission of a comprehensive transportation construction. Jackie Wang Guoyu, President of Global Transportation Business Unit of Enterprise BG, Huawei, will give us some food for thought on cloud-based, digital, intelligent, the new paradigm in comprehensive transportation.
Hello everyone, welcome to Huawei Global Transportation Summit. I'm Jackie Wang Guoyu, the head of Huawei Transportation Unit. As you know, the digital economy has been a key driver behind economic growth worldwide. Digital technologies like 5G, cloud computing, big data, IoT, and AI are increasingly used, ushering in the digital era for transportation. To digitalize the transportation industry, we need to work together. Huawei is excited to build a healthy ecosystem with industry partners. We are committed to enabling digital and intelligent comprehensive transportation alongside a new paradigm. In the future, transportation will expand beyond transportation passengers and goods in vertical domains, such as through rails, roads, water, air, and so on. It will be integrated and comprehensive. China has highlighted a lot of key tasks that will build national strength in transportation. As more industrial plans are proposed, such as the outline for building China's strength in transportation, guidelines on developing comprehensive transportation network, as well as regional plans from Yangtze River Delta and the Guangdong, Hong Kong, Macau Great Bay Area, the transportation industry is heading into a new era. Countries like Singapore, Saudi Arabia, and the UAE are also making long-term plans to keep in pace with the development of the digital industry. Huawei launched the comprehensive transportation concept in 2020 and has practiced with our ecosystem partners. For example, Tianjin Port Group, Yunnan Communication Investment and Construction Group, Shenzhenbaum Group, and so on. In terms of digital comprehensive transportation, I'd like to focus on three flows, that is, passenger flow, goods flow, and carrier flow, providing more personalized, differentiated, comfortable, and convenient travel experience for passengers is the aim of various transportation enterprises. As such, passenger flow is the most important. The second important is goods flow. Smooth circulation of goods can improve logistics efficiency and reduce the social costs, helping us achieve convenient travel and smooth logistics. Third, intelligent carrier flow, or we call it operational flow. Resources and requirements can be better matched by linking elements such as passengers, goods, roads, vehicles, yards, and stations. How do we use digital methods to improve these three flows? For passenger flow, we use OneID and MARS to connect various travel modes, providing passengers with one-stop smart experience. For goods flow, we promote the interconnection between information systems on aviation, railways, roadways, and waterways, and allow electronic waybills and mutual recognition between them with one another. This solution provides end-to-end visualized and traceable one-stop logistics services and supports multimodal transportation, improving logistics efficiency, saving energy, and reducing emissions. Lastly, for carrier flow, we propose use one map with digital technologies to make carrier operations easier and more efficient, and ensure scheduling is accurate and proper. Huawei's future comprehensive transportation covers people's door-to-door journeys and end-to-end transfers of goods and make them greener, quicker, safer, and cheaper for better experiences. How can we implement digital and comprehensive transportation? By three things. First, build a full-service architecture. We need to digitalize both infrastructure and service processes so as to avoid scattered and siloed construction. Second, streamline entire service process, including passengers, goods, and carrier flows. Third, focus on the full life cycle, create a much larger market space for consulting and planning before construction. Develop more business models and provide diversified service methods from operations to business. These measures, as well as implementing the vision, overview, and roadmap, these are the key to achieving digital comprehensive transportation. Let's look at the vision. Our goal and the vision for comprehensive transportation is to achieve convenient travel and smooth logistics. There are several elements that can make it a reality. First, hubs connect various transportation modes and allow us to manage goods movement and distribution with efficiency and collaboration at the core. Regional connectivity will drive integrated economic development and will be majorly improved by convenient and smooth travel experience, multipath connection, as well as real-time and accurate sensing across all domains, periods, and elements. Urban transportation is important in our daily lives and fuel city development. Complex vehicles and passenger flows greatly affect transportation infrastructure and ecosystem. As such, we advocate green travel and work to improve people's travel experience. Comprehensive transportation will be digitalized first to improve efficiency, experience, security, as well as reduce carbon emission before achieving the vision. The overview of comprehensive transportation helps us streamline digital transformation solutions and break down customers' requirements. Based on the service capability framework, we can clarify what to do and determine the cooperation scope with our partners. We are using scientific and practical methods to help customers resolve their pain points. For example, Huawei is actively working with airports towards digitalization. To this end, we launched the Comprehensive Operations Control Solution, helping airports transform from passive to proactive control and from routine to exception management. This solution simplifies airport dispatching from 3 to 2 levels and reduces manual commands by nearly 30%. At the same time, Huawei's variable taxiing time prediction algorithm cuts 1 to 2 minutes of aircraft taxiing, helping airlines save nearly almost 15 million yuan on aviation fuel every year. At the Tianjin port, Huawei's unique cloud-controlled terminal autonomous driving solution enables the world's largest scale container trucks. The solution reduces construction costs by 30% and cuts down OPEX about 25%, helping the Tianjin port implement smart terminal transportation. Additionally, we deployed the intelligent shift scheduling solution for Shenzhenbaum Group, which automatically generates shift plans by collecting real-time data about passenger flows along with vehicles' locations and routes. This helps buses run on time. We also implemented the intelligent charging solution, helping charging new energy vehicles and thereby reducing low carbon emission. These solutions have helped transport operators save about 10% in costs. Together with ecosystem partners, we can develop complete end-to-end solutions with basic platforms and service applications. How can we achieve convenient travel and smooth logistics? The roadmap is clearly shown. From top-level planning and platform coordination to deterministic services, and ultimately to commercial operations. For services with uncertainties, we need to make uncertainties certain through joint innovation before commercialization. The vision, overview, and the roadmap clearly show that digital comprehensive transportation requires a scenario-specific solution. Based on Huawei's production portfolios, we need to work with partners across the industry to build and deliver end-to-end solutions and services to our end user. Huawei will integrate partners throughout the life cycle, including consulting and planning, system integration, application development, platform component, delivery and operations, to help customers achieve digital transformation. Huawei, in collaboration with our partners, has helped customers digitalize transportation construction across all services architectures with many success stories. We implement an architecture that uses a single central big data platform plus several branch data centers. This means that our solutions support all domains management and control, intensive construction, smart services, and industry innovation. Let's take a look at the reference of Huawei. It's from Yunnan Communication Investment and Construction Group. It was developed using its own highway backbone network. This solution costs 40% less than scattered construction, while also streamlining previously siloed system to centrally aggregate and govern data, as well as mine in-depth data value, enabling faster service rollout. Huawei helped the customer build smart highways faster by strengthening the data foundation in partnership with Sinfosoft and the Yunnan Science Research Institute of Communication. We also supported the fast deployment of industry application provided by Synaroad, Map ABC, Glodden, and Atide. Now, let's look at the rail industry. Huawei's smart urban rail solution digitalized Shenzhen Metro across all elements, all processes, and all scenarios. The Metro Group can easily view the full status of operations and increase their management efficiencies, thanks to the visualized remote management of metro engineering construction, alongside real-time monitoring of key operations indicators. In addition, Huawei's Urban Rail Cloud solution enhances platform security by 80% and increases IT resource usage to over 50%. We use one station as a template to develop services and then use the cloud platform to centrally distribute resources. We also adopt clone technologies to deploy real-time services in 20 stations with only 30 minutes. Huawei is a strategic partner for Shenzhen's metro's digital transformation. We are implementing industry-leading methods combined with our experience in digital transformation, allowing us to expand our partnership and combine our strengths across the entire project. That helped Shenzhen Metro become a best practice for global smart urban rails. The construction of digital comprehensive transportation requires multi-party cooperation. Huawei has established many partnerships in various fields and brought over 80 mainstream industry players together to develop scenario-based solutions, accelerating customer digital transformation. Following the platform plus ecosystem strategy, we aggregate industry SaaS partners based on the digital platform to build a thriving transportation ecosystem. As you know, transportation is a major part of our daily lives, including freight, logistics, and production, which are closely linked. Huawei is excited to work with our partner to drive digitalization across the transportation industry. By integrating SaaS partners, we will achieve comprehensive transportation. That's all. Thank you for your attention.
It is amazing how technology has evolved and are helping society to enjoy more convenient mobility that is green, safe, reliable, and efficient. Thank you, Jackie Wangguoyu, for this great sharing. Now, without further ado, I'd like to introduce our next speaker at the Transportation Summit. We are honored to have Hongshua Daven, UIC Director General, as our guest speaker. Now, let's welcome him to introduce us on UIC's perspective on the digital transformation for the railway industry.
Ladies and gentlemen, dear colleagues, I'm very honored to be intervening today in the Huawei Summit to speak about digital transformation in the railway industry on behalf of UIC, the International Union of Railways. As we all know, the world is being dramatically changed for already many years. The sanitary crisis we have been living since early 2020 has once more changed the transport industry. After having been almost totally stopped during numerous months, activity has restarted, and the need for mobility, for passengers and for goods, is now even more strategic than it was before the pandemic. Future transport has to be safe, efficient, frugal. In a nutshell, it has to be green. We know that rail is 6 times more energy efficient, emits 9 times less CO2 and reduces the number of road casualties significantly. So if we look at the big picture, we know that rail is already part of the solution for decarbonizing transport. But we have to achieve, for that, a massive model shift. And we have to do it fast. We have 10 years for implementing the UN strategy, avoid, shift, improve. It's very short. If I may quote John Maynard Keynes, in the long run, we will be all dead. This quote used to be a joke between economists, but now it's actually true, especially if we read the last IPCC report. But to turn this model shift into a reality, we know the new trends. Promote clean fuel, innovative transport, innovative solution, telematics application, enhancing safety. But I would say that today, the central issue will be how to select the transformational project that will be able to reshape the current mobility paradigm in a very short period that is still left before we damage our climate without remedy. Digitalization will lead to seamless interconnection with other modes and capacity increase. And so it has a central role to play in the decarbonization process. Digital project will be a driver for the modal shift to rail and public transport in order to achieve the objective of the SDGs fast enough to have an impact. Let me take here some practical use cases. First, for international corridor, the careful definition of administrative bottlenecks will be key. Well, we all know what are the administrative bottlenecks, the custom formalities, the different administrative environments, but what is new today is that digital tools are offering us the opportunity to overcome those different and sometimes conflicting legislation. In particular, it will be crucial that collectively we can, at the global level, work on international digital platforms that could be interfaced together and provide secured and flexible solutions for the international corridors that tomorrow will connect continents. UIC, as the International Union of Railways, is keen to provide the forum where the different networks can work together toward this practical unification. We don't have to wait the revision of the international convention that will take a time that we basically don't have anymore. Second example, development of future infrastructure will also be a priority because it will not be possible to increase the modal share of rail without increasing this capacity. But in the short term, we should focus also on introducing digital technologies that will increase the capacity and the reliability of the existing infrastructure while allowing multimodality. The new infrastructure must be made intelligent to optimize existing system usage. This belief is already shaping how we design future networks. Those developments will revolve around automated train operation, ATO, that already exists, the Internet of Things, and artificial intelligence. Third, the customer experience must be revolutionized through the creation of seamless intermodal transport chain that places railways as its backbone. Digital solutions for innovative transport with measurable impacts are under development. Let me explain some UIC projects. First, UIC develops FRMCS, Future Rail Mobile Communication System, that will provide a 5G backbone for railway, allowing the implementation of innovative network management solutions. FRMCS is a major opportunity to converge the applications managing the operations for basically any time of guided rail mobility. It will drastically simplify numerous technical aspects of intermodality between railway and other modes of transport. Second, UIC is active on the modeling of the rail system. This also is a key issue for developing a shared vision of what should be the transport architecture, favoring an appropriate modularity of railway components. Third, we are also launching a pioneering project on artificial intelligence. The combination of those three processes will enable the creation of what we call digital twins for the various networks. Indeed, having the possibility to replicate digitally our very complex networks will lead to a quantum leap in terms of efficiency and reliability. This technology will allow real-time simulated-based network management, complex concept, but basically it means that decisions, which today implies a costly and a very lengthy coordination process, would be taken in seconds. The last aspect I would like to insist is that we can draw today a credible perspective that in the next 10 years, rail will not become more disrupted despite the changing climate. Rail infrastructure will be more resilient to extreme weather conditions and other forms of disruption that will include health pandemics or changes in technology. Why? Because predictive maintenance technology, one of the other important activities in UIC, will allow for better operational resilience. Extreme weather warning systems and contingency plans are to be developed. Transport operators will share information, knowledge, and data in times of crisis on a scale and with the facility that we don't know today. So, as I come to a conclusion, I would like to insist that applying the hierarchy of avoid, shift, improve with integrated and intermodal digital approaches is central to reaping the full benefits of transport decarbonization. But having said so, it is ultimately behavioral changes that will ensure the success of decarbonization measures in the long term. And as a conclusion, I would like to insist on the virtue of frugality. That's a strange word, but we have to rediscover frugality since rail basically is frugal by nature, and we need this frugality to cope with the climate change. We are frugal in energy consumption, I said it many times, but we are also frugal in public space, whether in urban or rural area. The occupation of public space is minimal, and the promotion of public transport and rail will give back to our citizens the possibility to enjoy more public space with less noise, less pollution, and a greater level of safety. We are also frugal in terms of life cycle. The lifetime of rail, but also of tram vehicle, can be up to 30 years, minimizing the need of reinvesting regularly in non-renewable resources that will be increasingly scarce. Frugal because our systems are scalable. It is possible to upgrade the level of service in changing only parts of the system without relying on complete system changes. I hope that this short speech has been able to convince you that digital tools, if we actually put them at the very heart of the rail system and not as a gadget or as something to add up, will be instrumental to make a massive modal shift to rail not only a necessity, we all know that it will be necessary, but also something that will be desired, that will improve our life, that will design a future that will be better. Thank you very much for your attention.
Thank you so much, Mr. Davian, for your thoughts and insights from digitalization projects in the mainline sector. I'm confident that our audience will be excited to hear more from you and the projects undertaken. Over the years, Huawei has built a strong relationship with Heilongjiang Transportation Investment Group. It is our honor to have Mr. Shang Yunlong, the chairperson of Heilongjiang Transportation Investment Group, as our guest speaker. Mr. Shang Yunlong will present how digital transformation fuels the innovative development of Heilongjiang Transportation Investment Group, building China's first industry-leading smart logistics system.
Hello everyone, I'm very pleased to be invited to attend the Huawei Connect 2021 and talk to you on the theme of digital transformation fuels the innovative development of Heilongjiang Transportation Investment Group, building China's first smart distribution and transport logistics system. First of all, please allow me to give a brief introduction of our group and our business. Heilongjiang Transportation Investment Group, or HTIG, engages in investment and financing of transportation infrastructure, transportation capital management and debt management, cross-border logistics, trading in Northeast Asia, and mineral land resource development. We cover 10 areas of business, such as railway, road, aviation, marine, mining, logistics, and trading. Our mission is to be a pioneer of revitalization of Heilongjiang and a future leader in transportation. And we are keen to fulfill our social responsibility and do good to the society. We strive to be a first-class industrial investment group in the world with strong capital strength and sustainable development capability. Our group has the total asset of around 2,600 billion yuan. We are also the largest Heilongjiang province-owned company. We have transportation, mining, and land resource development and industrial finance clusters. We have built 6 core business segments: integrated transportation, facility, asset management, transportation service, resource development, transportation technology, and industrial financing. HTIG has attached great importance to the innovative application of new ICT technologies and the digital and intelligent transformation in fields such as smart highway, vehicle road synergy, and smart logistics. From 2019 to 2020, HTIG and Huawei and other world-leading ICT suppliers worked together to replace the provincial toll stations through digital and intelligent means. We managed to migrate the services with the lead time shorter than other provinces. We also delivered the highway video cloud networking project swiftly and with high quality. At present, under the new trend of dual circulations, with the focus on domestic circulation, modern circulation system development has become a national strategy. On September 9, 2020, General Secretary Xi Jinping stressed at the 8th meeting of Central Committee for Financial and Economic Affairs that as the logistics system plays a fundamental role in the national economy, the construction of a modern logistics system should be treated as a critical strategic mission. HTIG follows the national strategy of promoting logistics systems and the requirements of the 14th Five-Year Plan to build logistics hubs for the provinces, logistics and distribution planning. We will work to synergize the infrastructure network operations organization network, and smart information network for end-to-end smart operation. At the infrastructure network level, HTIG is planning to build the so-called 1357 logistics network. Harbin Suihua will be the center connecting all 13 cities and 5 ports in Heilongjiang province. At the same time, the 8 transport lines listed here form the main skeleton covering the logistics of the whole province, connecting to the whole country and serving as a gateway to the whole Europe and Asian continents. Such network have become the engine of international and domestic growth. HTIG has completed the overall architectural design of our smart logistics hub with Huawei based on the overall planning of logistics system in Heilongjiang province. In addition, we plan to build the first smart logistics platform that covers logistics and warehousing in Heilongjiang and even extend it beyond the province and beyond border with the support of partners. We have preliminarily developed 4 types of use cases, which are smart campus, smart warehousing, transportation management, and smart cold chain, and more than 20 sub-service scenarios, including security protection, energy efficiency management, merchant management, and vehicle route planning. We aggregate data collected from the digital platform to make services visible, manageable, and controllable, support digital logistics operations, optimize business processes and efficiency, and help operation companies increase revenue, reduce costs, and improve efficiency. In H2 this year, HTIG plans to invest in 5 parks: Harbin B-type bonded zone, Harbin comprehensive bonded zone, and parks in Suifenghe, Fuyuan, and Jiamusi. In the future, 20 more parks would be built depending on the overall progress of park operations. The numbers are subject to changes. HTIG smart logistics system construction expands from points to lines to network and form a layout of hubs and backbones featuring the integration of 3 networks. We will steadily promote the domestic and international circulations and achieve the goal of building a leading logistics and distribution system. We will have 3 stages. The first, smart logistics hub, building a multi-level smart hub network around 27 national logistics hubs in 5 types. Second, smart transportation organization. We provide one-stop integrated transportation services to enrich simple campus functions. Third, consolidating Heilongjiang Transportation Investment Group's logistics infrastructure and develops advanced supply chain services such as cross-border e-commerce, bulk commodity platform, comprehensive material trades and finance for Northeast Asia, thereby boosting industry prosperity. Our current smart logistics hub solutions has these features. First, through data-driven one-stop smart multimodal transportation services, Internet plus material trading ecosystem platform, we aim to drive the transformation and upgrade of Heilongjiang industry and help build a hub plus channel plus network logistics system, enabling unified management of logistics hubs, information exchange, and efficient collaboration between business functions, providing the most professional cross-border e-commerce services for Russia and Northeast Asia, improving the circulation efficiency and helping the group in quality and efficiency. And for the logistics parks operators, intelligent park and other supporting services are provided to reduce their cost and improve their efficiency of operation. And at the same time, we can attract more high-quality large enterprises to the logistics parks. This helps park operator to shift from pure tenancy business to being a multifunctional logistics service hub. Third, innovative ICT technologies such as cloud computing, AI, big data, IoT, GIS, and machine vision have been applied to the core logistics process, helping the group build an integrated smart logistics hub platform. In this way, traditional services can be made digital and intelligent, reducing costs and improving quality and efficiency. Fourth, digital platform is open and scalable. HTIG has a large number of logistics hubs and services. The logistics hub design focuses on the need of the group as a whole, and we adopt the group-level digital platform plus branch facility design. Group services are deployed on the cloud platform. Edge devices are deployed in the branches for interconnection. Layered and domain-based management supports fast service rollout. Fourth, we have good scalability. In the future, the smart operations platform will be enabled to work with the group's logistics operations portal website, the Northeast Asia Information Harbor, and the logistics resource trading platform, and become a digital carrier for major domestic logistic channels and port logistics, domestic international resource coordination, and connects the industry chain, supply chain, and logistics chain. Such design can evolve and protect investment. It supports deployment of multi-services in the current parks and also the addition of new parks and new services. Here we have a video to show the content of the IOC of our smart logistics hubs. The IOC provides comprehensive analysis of transportation channel and campus throughput, storage capacity. It makes use of big data analytics, AI, and real-time surveillance video to get the overall operations posture. Please show the video. To meet the needs of Heilongjiang logistics industry upgrade and Northeast Asia cross-border logistics trade platform, we build a centralized logistics network and smart logistics platform that provide visibility of transportation channels, park throughput, and comprehensive analysis of warehouse capacity and business operation data. We use big data and AI to visualize the status of each service, and we have real-time surveillance video. Going into the smart campus, based on the data aggregated by the digital platform, the status indicators of each service in the campus, such as transportation, warehousing, operation, and campus, are visible, enabling digital operation. We can see video image and alarms about security protection and services in the campus in real time, keeping the campus secure. Intelligent warehousing system analyzes the warehouse data such as goods information, warehouse capacity, utilization, and storage time, dynamically adjusts the warehouse capacity arrangement, and improves efficiency. Digital and automatic warehousing solutions are adopted to achieve efficient, safe, and convenient operations in warehouses and unloading platforms. The smart coaching system displays data of cold warehouses and cold chains, including inventory data, vehicle data, production and sales data, and product origin data. It provides visibility of the low power consumption of cold warehouses and cold chain transportation, and assists decision-making, supporting synergy between warehouses and cold chain transportation services. The transportation management system is based on map information and visualize the entire transportation process. It provides readily available transport network solutions for orders by matching capacity and channels. It allocates the right resources, provides dynamic tracking of vehicles, and monitors operation and accident handling to ensure safe, efficient, and accurate transportation. During the digital transformation and development of our logistics system, HTIG, Huawei, and many SaaS partners come together as a community. We must work together to come up with the top-level design, implement it in stages, and work towards a common goal of success. Heilongjiang Transportation Investment Group will continue to work with Huawei and other partners to build a logistics ecosystem alliance and an industry-leading smart logistics system. Thank you. I wish the event a big success. Thank you.
Mr. Shang Yulong, thank you again for your great insights. Now, let's learn about the development of the global road industry. Umberto de Preto, IRU Secretary General, has some exciting details on how the IRU approaches these developments and how technology is helping to achieve these objectives.
Hello to all our friends at Huawei and all participants of Huawei Connect who are with us today. The tagline for this year's event, Dive into Digital, is very appropriate. It gives us a sense of adrenaline that comes when you stand on a high diving board, looking down at the water with a sense of both fear and excitement running through your body at the same time. To jump or not to jump? Well, digital transformation is unstoppable in road transport, as in many other sectors. The question is not whether you should dive into the water or not. The real question is how to dive in. IRU is the World Road Transport Organization, the voice of more than 3.5 million companies running road transport services and logistics and mobility globally. These include the operators and shippers who run the 60 million heavy-duty trucks on the world's roads today. These are the companies that had to accelerate digitalization during COVID to keep transport moving. And looking beyond the pandemic, these are the companies that know that diving more deeply into digital makes road transport not only more resilient to trade or supply chain shocks, but also makes it safer, greener, and more efficient, thus boosting trade, fair competition, prosperity, and peace. I'm very proud to count Huawei as one of IRU's global corporate members. We share a belief in digital connectivity and transport and, importantly, why it is so important for our sector. Our already very digitalized world, fortunately, has helped us through the pandemic. And COVID has accelerated what was already a rapid rate of digital transformation. According to a survey from McKinsey, companies adopted digital change between 20 to 25 times faster than before the pandemic. Digitalization will also help our communities and businesses recover from the pandemic, as much as it helped us survive the initial crisis. Road transport plays a crucial role in the world's supply chains. It performs a wide range of duties, but its flexibility is most crucial as the first or last mile of any logistics journey, and as the connector for all other modes from port, airport, or station. In short, no global supply chain functions without road transport. And the continued digital transformation of road transport services is therefore crucial to the world's economies and all societies. Today, I would like to outline 4 major areas of digital transformation in road transport. But first, let me run through some of the big trends that form the backdrop to how our industry is digitalizing. Technology itself, of course, continues to evolve rapidly, from microprocessors to truck design to global cloud-based platforms, blockchain, artificial intelligence, self-driving vehicles, the Internet of Things, edge computing, 5G, and eventually 6G are all transforming how we move goods by road. It is not any one of these things alone that will drive change, but all together. Globalization in trade and supply chains is also continuing despite geopolitical hiccups, protectionism, and COVID. International road freight demand is forecast to double in volume by 2050, according to the OECD's International Transport Forum. Because basic economics, producing and delivering a good or service in the most efficient way possible, tends to outweigh politics and pandemics, at least in the long term. Safety has always been the commercial road transport sector's top priority and remains a strong impetus for change, from digital enforcement and driver monitoring through to standards for future autonomous vehicles. Decarbonization is also driving fundamental change, which affects and is impacted by digital transformation, most notably in operational efficiency. Looking ahead, several decades into the future, we see multimodal road transport being completely paperless, with digital freight platforms and operator route management systems seamlessly integrated with fully digital ITS, road charging and enforcement systems. And those, in turn, fully integrated with client systems across global supply chains, adapted continuously with artificial intelligence using completely autonomous trucks that are fully carbon neutral. That's a very nice picture, and I think a very realistic one. Nevertheless, there are some key challenges in getting there. Global standards are now more important than ever, from moving goods across a border to developing new vehicle standards or measuring CO2 emissions. IRU has driven global standards for more than 70 years because we see how important this is in the digital as well as in the non-digital world. Good governance, along with visibility in transport management and data protection laws, will make digitalization fair and bring the most benefit as all players along supply chains feel comfortable in sharing data for the greater commercial good of all. And finally, a global approach needs to bring digitalization to developed and developing countries alike. In a world of multi-connected, multimodal supply chains, even very local climate, safety, worker, regulatory, or border issues are essential global issues. Now let me turn to 4 major areas of digital transformation on the road transport horizon. Firstly, infrastructure. I have often said that the hardware of road transport, the roads, bridges, and customs posts, are worthless without good software, the standards, regulations, and processes used to move goods from one place to another. Paper, unfortunately, is still a key ingredient of international trade. IRU is working with the UN on fully digitalizing the tier system for customs transit and the digital protocol to the CMR Convention, the international standard that governs the commercial and legal aspects of road freight movements. Many companies, including Huawei, have stepped in with the new digital and connected ITS solutions for road and traffic management, especially on highways and in urban areas. These systems are now being increasingly integrated with onboard devices, especially in commercial trucks, buses, and coaches, starting with navigation systems but extending to safety and monitoring systems. The next challenge is for these systems for traffic, parking, tolls, and enforcement, amongst others, to be fully integrated with digital freight exchange platforms, as well as individual company logistics, routing, and fleet management systems. This will also boost the resilience of supply chains. If a pandemic affects factories in one part of the world or a ship blocks a major route, as happened recently in the Suez Canal, systems can adjust rapidly and keep supply chains moving. Secondly, at the company level, the platforms I mentioned are also well on the way to full digital transformation. Operators and shippers are at the heart of IRU, and I know many of them have prioritized innovation for a long time. In short, because better efficiency equals better customer service and greater profitability. From our members, 62% of road transport operators plan to invest in new fleet management solutions in the coming 3 years. And 53% of them, for example, expect digital fleet management solutions to improve transport security. It is worth noting that logistics operators are increasingly turning to new systems to manage human talent, moving beyond mass training to a digital approach that links in-vehicle monitoring with a digital skills platform to tailor driver performance. Thirdly, connected autonomous driving is also a major area of digital transformation in road transport. With up to 20% of driver positions in Europe, North America, and Russia unfilled in 2021, ongoing driver shortages are spurring digital innovation in self-driving trucks. More than half of shippers see autonomous trucks, along with safety, as their biggest innovation opportunity now. Indeed, the global autonomous truck market is forecast to triple from $460 million in 2024 to $1.5 billion in 2030. While the trajectory to the highest level of automation is long and there are many hurdles, there are huge possibilities in integrating autonomous trucks with the type of systems I have already mentioned to make road transport even more safer, greener, and more efficient. It will take time, but we're optimistic. Over 75% of transport operators and shippers globally expect autonomous trucks to become viable in fleets within the next 10 years. Finally, while reducing CO2 emissions may seem to be more a question of fuel technology, there are important operational factors that are also driving digitalization. Although commercial road transport accounts for 2.5% of global emissions, over 98% of the 60 million heavy-duty trucks on our roads are currently fueled by diesel. Renewing the global fleet and steadily introducing new fuel technologies as they become operationally feasible is a big job that will take time. However, operators and shippers are also investing in digital systems to improve operational efficiency in order to reduce CO2 emissions. IRU's Green Compact for commercial road transport to become carbon neutral therefore also includes a pillar on operational efficiency in logistics to cut annual CO2 emissions by 700 million tons by 2050, or 20% of the total needed. Happily, making transport more efficient and greener also improves profitability. I will conclude here by reinforcing the point that operators and shippers have long driven innovation from the ground up, and that this is continuing with the accelerating digitalization we see now. At its simplest, road transport is highly competitive, and digital advances make transport and logistics more efficient, as well as safer and greener, and are enthusiastically embraced by the sector. Challenges remain, and IRU is working with our members on global standards, digital governance and transparency, and a global approach to digitalize in developed and developing nations alike. Finally, thank you to Huawei, one of our most innovative members, for inviting me to speak to you today, and for developing and bringing to market so many innovative solutions that help the road transport sector advance. Thank you all for listening. 谢谢.
From the previous speakers, we have learned a lot about comprehensive transportation, railway, logistics systems, and the road sector. Now, Mr. Yang Shizhang will introduce us to the specifics in the aviation sector. More precisely, the airport cluster, with its topic, Going Digital to Develop the Airport Cluster in the Guangdong, Hong Kong, Macau Greater Bay Area.
Distinguished guests, it gives me great pleasure to attend Huawei's Global Transportation Summit. I'm going to share with you our vision and practices about digital transformation at Guangdong Airport Authority. About Guangdong Airport Authority. Guangdong Airport Authority is a large state-owned enterprise in Guangdong Province. It builds global air hubs and promotes high-quality civil aviation development across the province. Currently, GAA runs 6 airports, including Guangzhou Baiyun, Jieyang Chaoshan, Zhanjiang, Meizhou, Huizhou, and Shangguan, and manages 5 member units. Among them, Guangzhou Baiyun International Airport is one of the 3 major aviation hubs in China. Jieyang Chaoshan, Zhanjiang, and Meizhou airports are Category 1 aviation ports in Guangdong Province. In 2019, GAA's airports handled over 86.95 million passengers, or 3/5 of total passengers in Guangdong. Guangzhou Baiyun International Airport alone handled 73.38 million, ranked number 11 in the world. Baiyun Airport has been rated as one of the top 10 airports with best service for many times, and its Terminal 2 is ranked at 5-star. In 2020, GAA ensured smooth travel with proper pandemic control measures. Baiyun Airport handled more than 373,000 flights, 43.76 million passengers, and 17.6 million tons of cargo, becoming the airport that rebounded fastest from the pandemic, handled the largest number of passengers and flights in China, and also the number 1 in the world by traveler throughput. In ACI's Service Quality Survey, Baiyun International Airport was ranked as number 1 along with other airports. This year, Baiyun Airport has been certified with the highest 5-star COVID-19 safety rating. ICT is leading an intelligent revolution in science and technology and industries. Digital economy is booming with new technologies, new business models, and new patterns. Civil aviation industry is being reshaped in its business models, patterns, and the landscape. During the pandemic period, digital technologies such as big data, cloud computing, artificial intelligence have been quickly deployed, applications like QR code-based tracing, smart thermal temperature screening, non-contact service have facilitated air travel while ensuring passenger safety. China's civil aviation industry is flying into a smart aviation era. CAA follows the trend and aims to be a world-class airport group through digital transformation. We spare no efforts in making our airports smart. By making our business smart, we ensure traveler safety and deliver genuine service. Technical factor adoption rate of our airports is ranked top among tens of millions of airports in China. With this, we gain greater operation efficiency and quality and can deliver better travel experience. We set up a group operation and control center to have visualized smart monitoring and coordination operation. Our airports have deployed ACDM system. Guangzhou Baiyu International Airport is thus equipped with the most powerful brain. In 2020, its normal flight release rate was over 90%. Thanks to a leap from operation and control in minutes to seconds, Baiyun Airport's flight on-time rate is also ranked top in the world. Our airports have realized fully paperless travel. Guangzhou Baiyu International Airport was the first airport in China to promote One ID end-to-end self-service. We're leading in the adoption of express channels, luggage tracking, airport pass, and other new technological applications, as well as the building of smart airport in civil aviation industry in China. Next, I would like to share our vision of digitalization. Given the current trends in our industry and in the world, as well as our own strategy, GAA is determined to carry out digital transformation. Starting from June 2020, GAA worked together with Huawei to plan for our digital transformation. We set up a joint team of over 100 people, held 334 workshops, conducted 126 field surveys, and 23 dedicated training to share ideas, gain insights, identify gaps, and lay out a blueprint as well as a steady path to digital transformation. Our vision is to build a digital airport, help shape the digital aviation ecosystem, and connect digital transportation and cities. Digital first, customer experience first, and platform plus ecosystem are our three major strategies that guide us to build a first-class international airport group and take the lead in digital transformation among airports and SOEs in China. To realize our vision, GAA will push for transformation in 6 domains and achieve 6 ones. The first one is One Cloud through IT transformation. We will build new infrastructure using 5G, cloud computing, big data, IoT, AI, blockchain, and other next-generation technologies to set up GAA's digital foundation. Then we'll migrate to cloud for cloud-based airport services. Data middle-end platform, service middle-end platform, and AI or knowledge middle-end platform will be built to better provide digital services and empower digital innovation. We also plan to accelerate adoption of innovative 5G applications to connect everything. The second one refers to One ID realized through service transformation. Oriented around passenger flow, we will tap in AI, Internet Plus, biometric recognition, and other new technologies to create One ID for end-to-end seamless self-service, making travel more efficient. Our group website portal and airport pass application will be redesigned to provide end-to-end, personalized, and targeted online services. Passengers only need a smartphone for smooth travel. The third one is One Map realized through operation transformation. Oriented around flight flow, we will transform to facilitate precise control, full coordination, targeted command and control, and smart decision-making. Our goal is airport-wide coverage, full process control, operation within seconds, and precise control. It's like our airports will have a smart brain for operation and control and bring us greater efficiency. At group level, we will build a unified operation and coordination platform to support integrated operations and efficient airport cluster. The fourth one refers to One Network realized through security transformation. Security control is relevant to all scenarios. We will digitalize all areas, as well as the front end and back end of our systems to build an integrated security management and control system with full sensing, full risk control, and incident prevention. That means our security control is more precise, smarter, faster in response, and fully coordinated with one click. The fifth one refers to one platform realized through management transformation. We want to have a value and process-oriented group. We will fully digitalize our process, coordinate services to have precise management. The end-to-end management system will be customer-oriented. Silos between departments and units will be broken for integrated business and financial management and full lifecycle management of employees and assets. The last one refers to one industry chain realized through model transformation. We fully embrace digital economy and are exploring new business models to transform from a conventional service provider to a digital service operator. Big data and AI will assist us in capability monetization through the new Internet Plus model. That can be our new sweet spot. We also plan to create a smart business platform and an integrated digital aviation logistic platform for a digital aviation ecosystem. Next, I would like to share with you some of our thoughts about smart transportation. In the future, with service alignment and data sharing, we will be able to coordinate more efficiently in different scenarios. Scenarios of coordination not only within an airport, but also between airports within one airport cluster, between airports, airlines, and air traffic management authorities, and between airports and other transportation modes, as well as smart cities. The first thing we're thinking is we need a unified platform at group level to support our airports and coordinate airport clusters. GAA will build a unified, efficient digital platform, cloud infrastructure, and network connections for resource sharing. The unified digital platform is accessible by different departments and units with one-stop and on-demand. Agile digital services can better empower digital innovation. We will accelerate the adoption of 5G and other next-generation mobile communications and help push for network convergence. That will prepare us for Internet of Everything for full awareness of status and data acquisition. The second thing we are thinking is we need to coordinate efficiently with external institutes for integrated civil aviation system. The civil aviation system chain includes not only airports but also airlines and air traffic management authorities. To handle flights, ensure flight security, and have operation, command, and control, all the three parties need to collaborate closely. GAA plans to adopt digital technologies and enable smart and automatic data acquisition to encourage airports, airlines, and management authorities to share data and open interfaces. Then we can realize flight flow-oriented, end-to-end seamless data coverage, integrated air-ground systems, and a smart airport ecosystem. The third thing we're thinking is airports need to coordinate with cities and other transportation modes to build integrated transportation systems for smart cities. Smart airport is an important part of a smart city. Airports need to coordinate with cities' development and share resources. GAA will coordinate with other transportation modes to build airport-oriented integrated transportation system and connect smart transportation and cities. By aligning IT systems, we can let each transportation mode play its role and get maximum efficiency. If airports can dynamically sense traffic flow and give predictive warnings for coordination, traffic in city hubs can be balanced by regulating demand and supply and offering travel tips. In this way, people, vehicles, and roads are better coordinated for better travel experience. The human society has experienced multiple revolutions. Each time new technologies disrupted our work and life, we are ready to pour more wisdom, leverage digital technologies for in-depth convergence, and fully push for digital transformation to make GAA a world-class output group, to promote intelligent output cluster in the Greater Bay Area in China, be part of the integrated transportation in that area, and contribute to smart transportation and smart cities. I wish the summit a great success. Thank you.
Thanks for great speech about aviation from Mr. Yang Zhijiang. Following the aviation insights, we will have a quick look on Huawei's products, designed to help achieving these goals through digital transformation. Let's welcome Mr. Richard Jin, the president of Optical Business Product Line, to learn about Huawei's NHP Trustworthy Network for Rail Transport.
Hello everyone, I am Richard Jin. I am pretty sure that most of us have taken a train before. In Shenzhen, I mostly take trains, either the subway for commuting or the bullet train when I travel to other cities. I find it a lot more efficient since there are no traffic lights or traffic jams, making rail transport safe, fast, and punctual. Communication networks are similar to rail transport. The best communication network must be highly reliable, low in latency, and deterministic. The hard pipe network is the only technology in the industry that can meet these requirements. It uses physical isolation to allocate dedicated channels to services, preventing services from affecting each other. There are three types of physical isolation. The first one is spatial isolation. It is similar to multiple trains running on parallel tracks. On a communication network, a dedicated optical fiber is allocated to each service, and multiple optical fibers from an optical cable. This technology is called Space Division Multiplexing, or SDM. Then there is frequency isolation. It is similar to the isolation of train carriages. On a communication network, different services are carried over different frequencies. Although these services are transmitted in the same optical fiber, they do not affect each other. This technology is called Frequency Division Multiplexing, or FDM. The third type is time isolation. It is similar to a train timetable. On a communication network, time is divided into several time slots, and each service sends and receives signals only in its own time slot. This technology is called Time Division Multiplexing, or TDM. These three isolation types divide physical resources, so there are real physical isolation. Rail transport implements physical isolation through tracks, carriages, and timetable, making it the best way to travel. Similarly, only physical isolation technologies, SDM, FDM, or TDM, can be used to build a hard pipe network with high reliability, low latency, and deterministic experience. The industry proposed the concept of hard pipe network in 2013, which has been widely applied in the rail transportation. So far, there are two generations of hard pipe networks, PDH and SDH. The third generation, featured by OSU technology, is on the way. Besides the physical isolation, low latency, hitless bandwidth adjustment benefit from OSU, The third generation will extend from the wide area network, or WAN, to the access network, creating an end-to-end native hard pipe or NHP network. Implementing hard pipe technology for access networks is a big challenge because there are thousands more terminals on access networks than on the WAN. This means that we need to make sure that this technology is both cost-effective and delivers the necessary technical performance. For this, we are looking to passive optical network, or PON technology, which has shown big success in access networks. PON has proven to be the most suitable technology for large-scale access. Now, more than 600 million homes around the world use PON for broadband access. With more than 30 years of technical experience in optical transmission and access networks, Huawei has combined the advantages of OTN and PON, proposing an innovative P2MP OTN architecture to build a native hard pipe for both WAN and access networks. Native hard pipe, or NHP networks, prevent the congestion and packet loss caused by services competing for communication resources. The reliability of key services reaches 99.999%, which means that services are only interrupted for less than 5 minutes over the course of 1 year. This innovation is critical for rail transport. Take the subway as an example. Most stations in China now use mobile payments. When entering or leaving a station, passengers need to swipe QR codes on the mobile phones. For this, subway operators have deployed the automatic fare collection, or AFC system, which bring two challenges for access networks. First, it adds many access devices, gates, and ticket vending machines must be connected to network. Second, services rely on networks more than ever. Both user experience and profits depend on the AFC system operations. So it must be highly reliable. If the network is faulty, thousands of passengers won't be able to travel, and subway operators will face serious economic losses. That's why subway operators usually build a dedicated access network, securing AFC system operations. This network is physically isolated from the existing passenger information system and the CCTV networks. However, this means that they need to manage many access networks at the same time, leading to high costs and difficult O&M. Now, imagine that as the subway goes more digital, there will be more and more services and systems. So, we will need more access networks. Instead, using Huawei's innovative NHP network solution, subway operators can just build one network. The NHP network can carry all of the existing PIS, CCTV, and AFC services, along with other new services, while assuring physical isolation. Both dedicated network usage and single network O&M are achieved. During Huawei Connect this year, we have launched an innovative product which converges WAN and access networks based on OSU for the first time. Further simplifying network architecture, this is like building a single station where the subway and high-speed railway converged together. After getting off a subway, passengers can directly get on a bullet train without security or ticket checks. How efficient is it? Thank you.
Huawei's optical product line has given great advancements to digital transformation, and together with Huawei's data communication product line, digital transformation and comprehensive transportation is now reachable. It is our honor to have Alex Sun as our guest speaker to tell us more about the bond between Huawei's communication products and digital transformation of comprehensive transportation with his topic, Intelligent Cloud Network Boosting Digital Transformation for Smart Airports.
Hi everyone, welcome to Huawei Connect 2021. I'm Alex Sun from Huawei Data Communication Product Line. It's my honor to be here, and my topic is Intelligent Cloud Network, Boosting Digital Transformation for Smart Airports. Nowadays, many industries are reaping the benefits from digital transformation, and the transportation industry is no exception. In particular, digital transformation of airports increases operation efficiency, ensures travel safety, improves travel experience, and helps build smart airports. In the global civil aviation industry, the three leading organizations are CETA, ACI, and ITA. Each puts forward positive proposals and suggestions for digital transformation of airports. For example, CETA's survey shows that 63% of airports have implemented or implementing digital transformation. ACI has also released the Airport Digital Transformation White Paper, which provides guidance for digital transformation of airports worldwide. And likewise, ITA has proposed a new experience in travel and technologies, or NextT. The purpose of NextT is to optimize the passenger experience and improve operation efficiency with the latest technology. And in the process of airport digital transformation, traditional IP networks face 4 new challenges. The first challenge is silo networks with limited interoperability. The result in data silos, which cannot support service deployment, such as intelligent stand allocation. Next, I would like to share with you the story of Shenzhenbaum International Airport. In the past, the airport relied on manual operations on the ORMS system for aircraft docking. For allocating stands, it relied on limited static data, which is inefficient. In fact, data about stands, railway directions, aircraft types, and passengers is distributed in many different systems. If such data can be streamlined and AI computing is performed, the aircraft docking rate will improve 10%, and this means about 2.6 million people are spared from taking the airside transfer bus every year. The second challenge is poor Wi-Fi access experience for passengers in the airport terminal buildings. This directly affects ACI's airport ranking. The third challenge is about security. After airport services are migrated to the cloud, traditional passive defensive methods cannot effectively protect data, such as flight and passenger data. The fourth challenge is about O&M. An airport may have over 140 airport applications and more than 25,000 devices, but manual O&M leads to low efficiency. As reported in news, the IT equipment system of an international airport in southern province of China was faulty, affecting services such as check-in and security check. Because the airport relied on manual O&M, services were not quickly recovered. As a result, all the flights that day were cancelled, and a large number of passengers were left stranded. In 2020, Huawei launched a new initiative called Intelligent Twins for transportation. It includes intelligent interaction, intelligent connectivity, intelligent hub, and intelligent applications. It builds a continuous evolving intelligent system through cloud, network, edge devices synergy. In this intelligent system, there is an important end-to-end datacom network. It covers the airport access network, backbone network, cloud data center network, and integrated security. In this way, such datacom network strongly supports the intelligent twins for transportation. Huawei works closely with the customer and partners. Today, I'll share with you Huawei's latest airport cloud network solution for the transportation industry. This new solution has 4 unique capabilities. The first one is one-stop access and Wi-Fi 6 continuous networking. Huawei is the only vendor who can provide 16 transceiver and 16 receiver smart antennas. This enables full Wi-Fi coverage without blind spots in the airport terminal buildings. Also, Huawei's intelligent AI algorithm ensures seamless roaming, preventing interruption to passenger service such as video and gaming. The second unique capability is one network for all services and IPv6+ enabling more innovations. We can build an IPv6+ based backbone network to interconnect each area in an airport terminal and interconnect airport terminals. In addition, the latest IP technologies are integrated into airport services to provide cloud network integration services. The third unique capability is one cloud across multiple areas and NAS. After airport services are migrated to the cloud, cloud data centers are distributed across wide areas. Automatic network deployment enables fast service provisioning. Intelligent O&M facilitates proactive prediction of 90% service faults. The fourth unique capability is one-stop integrated security and cloud network security collaboration. The value of airport service data becomes more important than ever. As such, a zero-trust architecture can gain real-time insight into network-wide security posture. Intelligent analysis ensures threat detection accuracy of over 96%. With the 4 unique capabilities, Huawei Airport's cloud network solution helps customers boost digital transformation for smart airports. At airport terminal buildings, Huawei Air Engine Wi-Fi 6 can deliver all-new wireless access to redefine travel experience. Our Air Engine Wi-Fi 6 adopts unique software and hardware innovations to achieve high-density continuous networking in airport terminal buildings. For example, our innovation 3D network planning tools support 3D signal simulation and roaming simulation. This can help the customer to get full visibility of signal coverage without blind spots. Huawei's unique 4-element smart antennas increase the coverage distance by 20%. Our unique AI-powered intelligent roaming algorithm enables the terminals to intelligently select access points. In this way, we can achieve seamless roaming with 0 packet loss or 0 service interruptions across the entire network. Airports have different services such as security check, security protection, retail, and ground handling. These services have different network bandwidth or latency requirements. Huawei's Airport Cloud Network solution can meet this by using NetEngine 8000 series routers and innovative IPv6+ technologies such as FlexE-based hardware slicing. This solution helps to build one backbone network to carry multiple services. By doing this, the customer can reduce repeated network construction investments and simplify network O&M. Services such as security check and retail need to be isolated due to different levels of sensitiveness. The Airport Cloud Network solution innovatively supports megabit-level hardware slicing. This ensures hard isolation of service traffic from over 1,000 applications. It also supports multi-network convergency and provides 100% bandwidth guarantee for mission-critical services. Cloud network security integration is another highlight that has 3 characteristics: accurate, fast, and stable. Especially, the average threat detection rate is improved from 60% to 96%. The threat detection time is shortened from days to minutes, and the threats are detected and handled in seconds. Such results are achieved with Huawei High-Sec Engine USG series, a terabit-level AI firewall. The maximum throughput is 2.4 terabits, which is 4 times than the industry average. It is also embedded with 12,000 IPS signature, which is 1.5 times than the industry average. Huawei's Airport Cloud Network solution keeps innovating to meet airport customers' expectations on security, efficiency, and experience. And by doing so, we help the customer to address many challenges in digital transformation. And currently, Huawei products and solutions have served more than 60 smart airports worldwide. Huawei's Airport Cloud Network solution is a gateway to the world. That's all for my presentation. Thank you for joining me. I hope you enjoy the event. Thank you.
And with that, we reach the end of today's summit. Thank you for joining us, wherever you are in the world. Thanks again. We wish you a safe journey, always, and look forward to seeing you again next time.